Crash Course Instrumentation, Episode 25, Conductors and Electrical Connections. Welcome to Episode 25 of Crash Course Instrumentation. In this series of episodes, we're exploring the full tutorial section of the Conductors and Electrical Connections model. Whether you're wiring control loops, troubleshooting field terminations, or working inside a panel, this first installment will give you a grounded understanding of what it means to build a sound electrical connection. Let's start with the atomic level basics. All electricity starts with mobile charge carriers, usually electrons in solid metal conductors. Conductors like copper work well because their atomic structure allows electrons to move freely. Silver has even lower resistance but is costly. Aluminum is widely used in power transmission due to its low weight, though its oxide layer and higher resistance require specific terminations. But motion alone isn't enough. For a circuit to function, there must be a complete loop of conductive material. That means good continuity from start to finish. No gaps, no breaks, no excessive resistance. You'll learn why continuity matters and how to ensure it. What separates conductors from insulators at the atomic level. How voltage, current, and resistance interact in real connections. The impact of material type and purity on conductivity. Why even slight corrosion or contamination can dramatically raise resistance. We'll also break down how connections are made and broken. How switches function by closing or opening a physical gap. Why even a tiny air gap can stop current flow, especially in DC circuits. What happens when materials like oil or corrosion get between contacts. The importance of surface preparation and contact maintenance. Dive into connection resistance. 1. More contact area yield less resistance. 2. Greater contact pressure equals more deformation and better electrical contact. 3. The microscopic view. Contact actually occurs at tiny asperities, not across the whole surface. 4. Low-resistance connections mean less voltage drop and more power to the load, especially critical in low-voltage sensor loops. Ohm's law and conductor geometry. 1. Resistance increases with length, RERLA. 2. Resistance decreases with cross-sectional area. 3. Conductivity is the inverse of resistivity and varies significantly between metals. 4. The higher the temperature, the higher the resistance. Learn how to choose and size wire. 1. Understand American wire gauge, AWG. Smaller numbers equal thicker wire. 2. How ampacity ratings are based on heat dissipation and insulation. 3. Why installation conditions, in air versus conduit, affect current limits. 4. The concept of derating for multiple wires in a single raceway. 5. The importance of matching terminal type to wire size and strand configuration. This is the first of several practical and foundational episodes covering real-world connection methods. Up next, we'll dive into splicing, crimping, terminal blocks, and temporary test setups. We'll also get hands-on with multimeter testing, thermal imaging, and identifying high-resistance faults before they cause failures. Watch all episodes. YouTube.com/Crash Course Instrumentation. Join the conversation. https://www.facebook.com/groups 17254229047375541. All instructional models used are courtesy of Tony Coupalt and the open-source ModL project, http://ibiblio.org Coupalt's Socratic Model Index.